This video demonstrates how to use the Server Migration Service to migrate data from an on-premise data center to an AWS EC2 instance. To install the Server Migration Service plugin, go to the AWS console. Under the Migration area, select Server Migration Service. A connector is a virtual appliance that is installed into your on-premises environment and is going to act as a connector between your on-premise data center controller and AWS infrastructure. If this is the first time you are accessing this environment, you will not see any existing connectors for performing a migration. Select Zero Running Connectors so that we can begin creating our first connector. Select SMS Connector Setup Guide. There are two options available for download, OVA and Hyper-V. Select the one that is appropriate for your infrastructure. For our example, we will use the OVA template. We will copy the OVA URL so we can use it in our VMware Management Console. In the VMware Management Console, we will select File, Deploy, OVF Template as the OVF template. Then we will paste the URL and select the Next button. Select Next again, and then specify where we want to install the connector. We will also give the connector a name. Select the cluster where the template will be deployed. Specify the storage details. On the disk format screen, select whether you want to deploy this machine as a thick or thin provisioning. This decision depends on your local administration's policy. Create the network mapping by selecting the destination network and select Next. Use the Ready to Complete screen to verify your setup, and if necessary, go back and correct any changes. Make sure you select the Power On after deployment option. Select Finish to complete the setup and have the connector deployed. Once the process completes, close the window. The virtual machine is now running. Configure it by selecting the name and opening the console. Use the username and password provided in the current documentation. To configure the connector, we will run the sudo setup.rb script. The first option we are going to configure is the network settings by selecting the number 2 for reconfigure network settings. Follow your local administrative policies for setting up the network settings. In our example, we will use a static IP address. Now that we have the IP address configured, let's open a browser, preferably Chrome or Firefox, and enter the local IP address to open the AWS Server Migration Service console. We will select Get Started Now. You have to accept the license agreement and then set up the password, the same one we just set up using the console. This screen gives you instructions for configuring the network, which we have already done, so we will select Next to continue. As a best practice, you will want to keep both of these options checked to upload logs automatically and AWS Server Migration Service Auto Upgrade. Upload logs is good if you have to troubleshoot. In case the conversion fails, uploading logs will help you troubleshoot that. Automatically upgrade is also good because we are always improving our products and we recommend using the latest version. The connector has two configurations to make it work from a security perspective. The first one is to provide AWS credentials for the connector to work. This is where you provide an AWS access key and a secret key for AWS. You must have a user with the minimal privileges to make Server Migration Service connector work. If you do not have a user created, you must create one. All the security information related to this is on the official SMS documentation page. Keep this screen open and return to the AWS Management Console screen to obtain the access key ID and secret key. From the AWS Management Console screen, locate the Security, Identity, and Compliance section and select IAM. From the IAM console, select Users. As you can see, there are users already created. If you did not have a user created, you would need to create one at this point. For our example, we will select a user from our list. Select the Security Credentials tab. From the Security Credentials tab, click the Create Access Key button. The access key ID and the secret access key display in a separate window. Copy and paste the access key ID and the secret access key to the AWS credentials fields in the Server Migration Service console. After you provide both the access key ID and the secret key access, you need to select the region where you want to migrate the servers. Select Next to continue. Provide your AWS endpoint, where your virtual machines are migrating to. In the AWS console, you must provide the source. By source, it means you must provide the IP address, username, and password for the vCenter Management Console. Create a vCenter role with minimum privileges and associate the user to the role, and enforce security best practices. In this example, we will choose to ignore the hostname mismatch and expiration errors for vCenter and ESXi certificates and select Next. To trust the certificate, select the Trust button. Select the Go to Connector Dashboard button to open the connector console. The connector dashboard shows some useful information about the connector. Now, let's return to the AWS connector. The connector is already running, so we are going to use another virtual machine to demonstrate Server Migration Services capabilities. We will use the CentOS demo as our source virtual machine. We will open the console for CentOS demo. From the console, we are going to create a couple of files that can be migrated. Now we have the server created, and the machine we are going to migrate has some files. We are going to return to the AWS console. From the Migration section, select Server Migration Service. Now you can see we have one running connector. Remember from before we had 0. Now we have 1. Select the one running connector link to see the connector details. You can see the connector information such as the connector ID, MAC address, IP address, which vCenter is connected, and the status, which is currently showing as healthy. The next step is to import the server catalog. This sends an API request to the connector, and the connector triggers an API request to the vCenter to lease out virtual machines that are managed by that specific vCenter. Select the Import Server Catalog button. Click Import. You can see all the virtual machines that are in the on-premise vCenter. Now we are going to create a replication job, which is the task that is going to migrate that specific virtual machine to AWS. We are going to search for our SMS demo to use for our first replication job. Select the CentOS SMS demo as the server we want to migrate, then select Create Replication Job. On this screen, we need to select how we are going to manage the OS licenses. We have the default license type as auto, but we can change this to use AWS licenses or bring your own licenses. Once you determine the best license type for your environment, select Next to continue. In the Configuration Replication Job Settings screen, the first thing we need to determine is how we are going to replicate this specific virtual machine. There are two options in Server Migration Service. One option is to do a one-time migration. A one-time migration means we are going to copy or migrate this server only once, and we are not keeping up with the changes or updates that happen to that server. The second option is to replicate the server at selected intervals, which means the Server Migration Service has one engine that takes snapshots of the server at specific intervals of time and only copies over the Delta files or files that have changed. For example, if we use this setting with the 12 hours selected, that means that every 12 hours we take one snapshot and we migrate or copy over only the files that have changed over that 12-hour time frame. The benefit of doing a replication at selected intervals is if we have a large server that has a lot of storage, instead of copying over 100% of the server each time, we only copy over the files that have changed during that 12-hour time frame, and our maintenance window is much shorter. For our example, we are doing a one-time migration. The other option you need to determine on the screen is when you want to start the migration. There are two options, immediately or at a later time and date. We will also need to provide an IAM service role. You can add a short job description with the name of the server and the job it performs. The final two options to configure are Enable Automatic AMI Deletion and Enable Notifications. If you set the Enable Automatic AMI Deletion to Yes, it only keeps a few of the latest snapshots taken. If you want to be informed when a new AMI is available, you can enable notifications. Notifications are great if you are looking for automation or you want to trigger a script every time a new AMI is available. Set the Enable Notifications to Yes if you want to be informed. In this example, we will not enable notifications and we will select Next to continue. This screen is a review of the migration settings. Check that the settings are correct. If you need to make changes, you can go back to the previous screen and make any necessary updates. If everything is correct, select the Create button. Once the replication has taken place, select the View Replication Jobs button to view the results. On this screen, we can see all the replication jobs in our environment and check the progress of each individual job. The first step in the server migration service process is to take one snapshot from the source machine environment and start uploading the snapshot to AWS into an S3 bucket. Once the upload finishes, we start a conversion process to get the virtual machine prepared to be compatible with AWS. This means we update the bootloader and install any network or drivers that are necessary to make it run as an EC2. Once we finish the conversion, the last step is to create the AMI and make the AMI available to launch EC2 servers. Now that the process is finished, the result is the latest AMI ID, and we can use the AMI ID to launch an EC2 instance. If you take a 12 or 24-hour snapshot to sync servers, every time the schedule runs, you will get a different AMI ID. Once the job is complete, the job no longer shows in the list. Return to the console and locate the section called Compute and select EC2 and then select AMIs to check your images. We have a new AMI created by SMS and we are going to launch the image by going to the Actions and selecting Launch. Select the instance type and size. For our exercise, we are using G2 Micro, but you can select any instance based on your requirements. So if you need more memory or more CPU, select the appropriate instance. Select Next, Configure Instance Details to continue. Select the number of instances to launch and configure the instance as you need. Once you have the configuration set up, select Next, Add Storage to continue. Here you can set up the disk size and storage. For example, if you need to add additional disk. Make the changes you need and select Next, Add Tags. On this screen, you can add tags to the instance to easily find it later. After completing the information in the Add Tag step, select Next, Configure Security Group. Then you'll want to configure a security group. Once you have configured your security group, click Review and Launch to continue. Use this screen to review your configuration. If you need to make changes, return to the screen you need to update before launching. If everything looks correct, select the Launch button. Next, you need to select an existing key pair or create a new key pair. Enter the necessary information and click Launch Instances. You see the new instances launching with the new AMI. It's the migrated version of the VMware machine we were working with before. The state changes from pending to running, which means it's booted up correctly. Now we will connect to the machine to check to see if it has the latest version of our server. We will open a command line and use SSH into the machine using the IP address. We enter the password, and now we are connected to the migrated machine. As you can see, if we list the files, we see the files we created earlier on the original machine have been migrated over. This completes the demonstration.